Join us for a tour of the Earth's processes. Welcome to GeoMedia. Did you know without a map, you can't tell the forest from the trees? Come on, I'll lead the way.
Maps. Without them, we wouldn't be able to get from here to there. Without a map, you might not know where you are. We've been using maps for hundreds of years to navigate the seas and coasts, to cross continents, and to journey out into the solar system. Maps not only show us where we are, but are a code for many other kinds of information. Symbols on maps show the physical features of the land, like elevation and the types of rocks that make up the landscape. Maps show the kinds of people or plants living in a particular place. Stories and myths about people often contain maps. The possibilities are endless. Maps have been drawn on clay, parchment, and paper. Today, people use computers to create maps that show spectacular views of our planet from space. Learn to read a map. It will lead you to unexpected treasures.
Maps show many different kinds of information, from places to people, from roads to rocks. Come take a tour of maps and how we read them.
A map can show any physical feature on the land that you want to see, including elevation. To show elevation, you can shade the map, or you can use contour lines. A map can show any physical feature on the land that you want.
Want to know what time it is? The Earth knows. It has its own clock, from seconds to billions of years.
Time and change. Two things that go together on our planet. If something changes, it happens as time passes. There are many rhythms. The tides each day, a child growing older, a storm brewing. And there are many clocks ticking on Earth. Some are very fast, like clouds and storms, moving in minutes or days. Others are longer, like the seasons changing from winter to spring. And then there is deep time, like mountains lifting and eroding, continents moving, and species like dinosaurs coming and going. Our planet is always changing, and we are part of the process of global environmental change.
Our planet is constantly changing, from waves crashing to continents moving. Do you know that the Earth sets its own record of change? Set your stopwatch and come find out how scientists measure time and change.
Scientists have outlined the Earth's history in a geologic time scale. The scale is subdivided by changes in life forms that existed on Earth at a given time. Fossils and sedimentary rocks are the key clues to understanding the geologic history of the Earth. The largest subdivisions of the scale are eras, followed by periods, and then smaller units, known as epochs. Cenozoic.
Extra, extra, read all about it.
Mesozoic. Paleozoic. Precambrian.
A greenhouse traps heat so that plants can grow. Did you know our atmosphere is like a giant greenhouse? Without the greenhouse effect, we couldn't live on Earth. Come find out how the greenhouse effect works.
If the Earth was the size of a basketball, the atmosphere would only be the thickness of a sheet of paper. A thin blanket protects the Earth. It is a veil called the atmosphere, and without it, life would not be possible. From space, the atmosphere is a blue-red, thin ribbon about 60 miles high. Our atmosphere is filled with gases that help trap some of the sun's energy. This process keeps our planet warm, just like the glass of a greenhouse. This invisible soup of molecules, gases, and sunlight is essential for life on Earth.
heat so that plants can grow. Did you know that our atmosphere is like a giant greenhouse? Without the greenhouse effect, we cannot live on this earth. Come find out how the greenhouse effect really works.
Deep within the interior of the Sun, tremendous heat energy is produced by nuclear reactions. Energy produced by the Sun travels through space to the Earth as waves of electromagnetic radiation. Short wavelength radiation is absorbed by gas molecules high in the Earth's atmosphere. Ultraviolet radiation is absorbed by the ozone layer. Some of the solar radiation is reflected back into space by clouds. Solar energy is also absorbed by the surface of the Earth. The warmed surface of the Earth then radiates heat energy out toward space. Greenhouse gases, such as water vapor and carbon dioxide, absorb some of the heat energy, trapping it in the lower atmosphere. The heat energy is then re-radiated back toward Earth. If greenhouse gases increase, more heat energy will be trapped within the atmosphere. An increase of a few degrees in the Earth's average temperature could significantly alter the variety of plants and animals that live in different climates. Deep within the interior of the Sun, tremendous heat energy is produced.
Carbon is everywhere on Earth. It's a basic building block of life. Like water, it has a cycle moving from gas to solid through space and time. Come learn about carbon in the air, the water, and in our bodies.
Carbon, a special atom that combines with countless others. Carbon is an essential building block of life. When many carbon atoms link together with water, sugars are formed using energy from sunlight. Oxygen is released as a part of the process. These sugars become food for animals who eat plants and who are in turn eaten by other animals. And as animals breathe, they give off carbon dioxide, another carbon molecule. As part of this cycle, carbon is also released by volcanoes. The carbon cycle is affected by human activities as well, like burning fossil fuels and forests. Carbon is absorbed by marine plants and eventually becomes part of the sediments in the deep ocean.
You may not know it, but carbon is essential for life. It has a journey on our planet called the carbon cycle. Want to know more? Check it out!
Carbon moves through a complex global cycle that has been going on for hundreds of millions of years. Like a giant regulator, the ecological systems on Earth work to keep the amount of carbon as balanced as possible. Plants absorb carbon dioxide and water during a chemical process called photosynthesis. Sea animals, like coral, store large amounts of carbon in the form of reefs. In the oceans, the largest amount of carbon is stored in sediments. Sediments are fine particles of organic matter deposited by wind, water, and ice. The carbon-based shells and skeletons of marine organisms collect as sediments on the ocean floor. Volcanoes emit large amounts of carbon dioxide into the atmosphere during eruptions. Sometimes rock particles and ash from volcanoes may stay in the atmosphere for several years. This may decrease the amount of solar energy reaching the surface of the Earth. Oil, peat, coal, and natural gas are called fossil fuels. A vast amount of carbon is stored in fossil fuel reserves in the Earth. When humans and animals breathe, they inhale oxygen. Carbon dioxide and water vapor are released into the atmosphere when they exhale. This process is called respiration. People have increased the amount of carbon dioxide found in the atmosphere. When we burn fossil fuels to heat our homes, drive cars, and run factories, carbon dioxide is released into the air. The balance of carbon on Earth and in the atmosphere is mostly regulated by natural forces.
rock, rattle, and roll. We're going to talk about earthquakes.
Nothing shakes you up like feeling the earth move. The very land under our feet seems so solid, but really isn't. Great forces come into play when the earth moves. Within minutes, a city or town can be left a mass of twisted steel, collapsed buildings and freeways, and raging fires. For the Earth, it is just a natural release of enormous energy resulting from forces at play miles beneath our feet. By understanding earthquakes, you can learn to be prepared for this natural hazard.
What is an earthquake? We all know it's when the earth moves and shakes, but what really happens? Take a tour to find out why earthquakes really occur.
An earthquake is an awesome natural hazard. Earthquakes occur all over the world. The Earth is made of many layers of solid and molten rock. The forces that create earthquakes occur in the crust and upper mantle of the Earth. The surface of the Earth is covered by a patchwork of giant slabs of rock called plates. The plates may be thousands of miles across and more than 40 miles thick. The lands bordering the Pacific Ocean are often affected by plate movement. Earthquakes and volcanoes frequently occur in this part of the world. This zone is called the Ring of Fire. An earthquake is an awesome natural hazard. Earthquakes occur all over the world. The lands bordering the Pacific Ocean. An earthquake is an awesome natural hazard.
Did you know that the same water you swim in might be the water that you brush your teeth with? Wow!
Water is life. A wonderful substance that takes many forms, from liquid to gas to solid. The water cycle is an endless journey. On Earth, water is moving in all of its forms: solid, Liquid, gas, high in the mountains, melting snows, and rain from clouds feed brooks. The water cascades down from heights and feeds streams that flow into rivers. Rain and snow fill ponds and lakes. Rivers swell and erode the land as the water continues on its journey to the sea. And here in the vast ocean of our planet, the waters evaporate to feed the clouds. No beginning, no end. A great cycle that enables all life to flourish on our planet.
Over 70% of our planet is covered with water. You can explore this section to learn more about it.
The sun heats the water and forms vapor. When cooled, vapor forms clouds. When warm, moist air rises and cools, water vapor condenses and forms droplets. The droplets form around dust particles and fall as rain or snow. Water falls from clouds as rain or snow into oceans, rivers, streams, and lakes. Rivers and streams eventually flow back to the ocean. Water seeps into the earth and collects between layers of soil and rock to form groundwater supplies.